All right, so last video we introduced continuous probability distributions. We used the uniform distribution as our example. From now on, the continuous probability distribution that we will see 99.9% of the time is called the normal distribution. And we talked about that in a previous video. And we went over the 65 or the 68, 95, 99.7 rule. And that was an approximation for finding probabilities under a normal curve. But it was only useful in very specific situations where the numbers involved were the numbers that were an even number of standard deviations away from that center point being the mean of any normal distribution. So in order to use these ideas for any normal distribution and to be able to come up with exact values, no matter what the mean is and what the standard deviation is, we have this very special normal distribution called the standard normal distribution. And what we're going to do is any normal distribution we come across, we are going to convert it to this normal distribution because this one is the only one that we have a table for, which gives us all the probabilities associated with this particular standard normal distribution. And we're going to call these values z's. We call them z-scores a lot of times, you'll see that. And the random variable z is distributed normally with a mean of 0 and a standard deviation of 1. So again, we're going to draw the same bell curve no matter what the mean and standard deviation is. What describes the difference between all of these normal distributions is what is the mean, what is the standard deviation. Here 0 is in the middle and 1 is the standard deviation. So positive z-scores go out to the right of the distribution. Negative z-scores go to the left of the distribution. So we want to be able to find probabilities associated with this distribution, and that's going to allow us to find probabilities associated with any normal distribution. So let's learn how to read the table, which I'm going to give each one of you a standard normal table, which you're going to keep with you at all times, and that you will, of course, need when you take tests, quizzes, assignments, everything else. So, we have a couple of questions here in order of kind of difficulty. So we want to answer questions. What's the probability that the random variable z is less than some number, greater than some number, or between two numbers? So those are the three cases that you'll come across. So if we ask this question, what's the probability in this distribution that a z value is less than -1? Well, 0's in the middle. We're going one standard deviation to the left. Now we could use the 68, 95, 99.7 approximation here to get this answer, but the table that I'm going to give you gives you more exact values. So we want to be able to depend on that for exact values because it's not always going to be 1 and 2 and 3. Often we're going to have numbers such as 2.13 or 1.71, and we'll need to use the table. So we're going to learn how to use the table right now. So less than values, greater than values, between two values. So the first one here, less than -1. Let's look at the table and see what I'm talking about. So here is the standard normal table that I'm going to give each one of you. And notice how this is set up. This is the standard normal distribution here, standard bell curve, 0's in the middle, and the z values are along this horizontal axis. So what this picture is telling you is that, so here you can't see it too clear, but this says z, and these numbers across the top are in the hundredths digit. These numbers are the tenths, up to tenths of the z value. So these are the z values. They range from 0 at the center, and it's a two-page table, first page, second page. First page gives you the positive z value. So the z value is to the right of 0. And notice again how this table is set up. When you find a z value in this table and go to find, and the numbers inside the body of the table are the probabilities. When you find the probability for a z-value, it's giving you the probability below that z-value, the shaded region. So these values in the table give you the probability that any particular z is less, or the outcome is less than any particular z that you're looking at. So for that first question, the probability that z is less than 1.0, we're going to use this column to go to the tenths and this column to go to the hundredths of whatever z value we're looking at. So 1.0 is here, and the hundredth digit is zero, also zero. This 1.00. So this number here, this 8413, is the probability that z is less than 1. But we were looking at negative 1, sorry. So we're going to go to the second part of the table, negative 1, negative 1.0, and look at that, because that was our question, probability that z is less than negative 1, is 1587. Okay? So that is our answer. So that's the easiest one when you're looking for z's less than, looking for probabilities less than some z value. Because all you got to do is look up the z value, negative 1.00, and you come down here, and that's your answer, 1587. And we look back at our board, and we see that is our result, 1587. So that's the amount of probability, and remember the total probability is 1. So 15.87% or 1587 is the probability that we're going to get a value less than negative 1 in this standard normal distribution. Now notice if we use the 68, 95, 99, 7 rule, we'd come up with 0.16, right? If you look at it that way, and that would be an approximation. What you see is pretty close to the answer, right? 1587. But this is more exact. So we want to rely on these tables for more exact answers. All right, so that's less than negative 1. Now what about greater than 1? All right, now if we go back to the table, but now when we look at, let's go back here, sorry. Greater than 1, we want this area here. But since the table gives us probabilities to the left of the number, and that's all the table can do for us, we're going to use the idea that the total probability is 1, and we're going to subtract off the probability less than the number we're looking for, and that's how we're going to get our answer. Okay, and the only reason we do that is because that's the way the table is set up. The table is set up to give us probabilities less than the z's we're looking up. Here we want the probability greater than 1, so we take the entire area under the curve and we subtract off the probability less than 1, and that's going to leave us with the area that we want. And now if we go look in the table, and we did that earlier, we looked at less than 1, it was 8413. Let's just review that. We go up here, 1.0, 0, 8413. So we subtract that 8413 from 1, and we get 1587. Now what I want you to notice here also is, that's the same answer we got for less than negative 1. Well, think about symmetry, right? We know the curve is symmetric, so of course that's going to be true, right? If we're looking at the value less than negative 1 on this curve, well, that's the same area as greater than positive 1, because the curve is symmetric, meaning it's the same shape to the right of the mean that it is to the left. There's the same amount of probability greater than 0, 50%, as there is less than 0, 0.5 or 50%. So notice these numbers are the same. Okay. So that's another thing to think about. When you're looking for the probability of z greater than some number, you can change that to the probability that z is less than the negative of that number and realize that that's going to give you the same result. So you can use this idea of complements, or you can use the idea of symmetry and say, I know the probability that z is greater than 1 is the same as less than negative 1. Just like the probability that z is greater than 2.5 is going to be the same as the probability that z is less than negative 2.5. All right, so two ways to look at greater than questions. The less than questions, those are the simplest because that's the way the table is set up. You just look up the z value, the number in the body of the table is your answer. Greater than, you can either use the idea of symmetry or you can use the idea of complements to get your answer. And lastly, when we're talking about the probability between two numbers, so here we want to know what is the area, what is the probability that in the standard normal distribution that you get a value somewhere between negative 1.71 and positive 2.13. So we're looking at this picture here. So the way you do between questions, again, think logically here. We want this shaded area. So if I take all the probability less than the larger number and then subtract off the probability less than the smaller number, I'm going to get the area that I want. Okay? So I'm going to take the probability less than the larger number. I'm going to look that number up in the table, and I'm going to see this. We'll go show you where this is. And then I'm going to subtract off the probability less than the smaller number, because that's going to leave me the shaded region here. So I'm going to look up 2.13 and negative 1.71. Okay, so 2.13, I go down the table to 2.1, and then over to 0.03, and I come down. 2.103 gives me that 9834. So that's the probability of getting a z less than 2.13. Now I'm going to subtract off the probability less than negative 1.71. So I use the second page of the table. I go to negative 1.7 over to the 0.01 column, and I see that number is 0.0436. So I subtract this number from the previous number, and I get my answer of 9398. All right, so standard normal distribution. I'm going to give you this table that we're looking at, and you want to be able to read it to find probabilities less than any z value, greater than any z value, or between two z values. All right, so this is an introduction to the standard normal distribution. We will continue on. Our next video will be converting any normal distribution to this one so that we can use these tables to find probabilities involving any normal distribution with any mean and any standard deviation. So that gives you something to look forward to, and we'll see you next time.